All right, we continue. I introduced triggering methods. I introduced the clock. I introduced the synchronize. I also introduced the synchronize. I introduced sequential circuits. With sequential circuits, we have asynchronous and synchronous circuits. Asynchronous, no clock. Synchronous, there is a clock. With the input of the clock, we have need to understand how the clock functions. The clock functions in timing. With timing, we have the frequency. Increasing the frequency increases the timing. With the clock, we have triggering methods. How does the state change? With asynchronous circuits, the state changes with the change in the inputs. However, with the synchronous, the state changes with changes on the clock. How does the clock changes? Those are the triggering methods we talked of. So we have edge triggering, we have level triggering. For edge triggering, we have positive and we have negative. Representation, how do you see this is a negatively or positively edge triggered sequential circuit? You see, but what I've just drawn on the diagram, there's a difference. There's a 0 here. I don't know whatever that is. There's a 0 here and this. If a circuit has this on it, it means it is a negative edge triggered circuit. If it doesn't have, it's a positive. I'll be drawing a lot of circuits here. You need to make, you need to notice these on the circuits, positive and negative edge triggered circuits. We have, we've dealt with the latch, the RS or SR latch. We now deal with the RS flip-flop. RS flip-flop. All right. We've dealt with the SR latch. Now we want to deal with the RS flip-flop. One thing remains the same between these two. They store information. How they store the information is how they differ. For the RS flip-flop, so in simple terms, this is a latch with an additional functionality of a clock. Latch plus clock. So a latch, a flip-flop is a latch with additional functionality of a clock. Now we have something like this. Block diagram, we have something like this. Our latch, it had two inputs, S and R, two outputs, Q and Q bar. This is the latch. With the flip-flop, we now have a clock. And that clock is edge triggered. Which type? Negative or positive? Participation.
Positive.
Positive edge triggered RS flip-flop. That's the difference between the latch and the flip-flop. Now we have a clock. Let's see how the clock affects the operation of this thing. As we can see, the flip-flops, they are now synchronized. It means the state can only change at a particular instant of time. The state now doesn't change with the change in the inputs. If SR changes, but the clock doesn't allow that change, it means we don't have a change. All right. Operation. Operation. This is the block diagram. Then for the circuit, it's still the same circuit, but we now have additional clock. Let's draw the NAND one. We have 4 NANDs. The logic circuit, we have 4 NANDs. 1, 2, 3, 4. My output, this is Q, this is Q bar. I have S, I have R, and this will be the input here, and this will be the output here. This is what is inside that block diagram. All right, but now I have 2 inputs here instead of 1. The SRLH, I think the SRLH is just like this. This is the SRLH, no clock, 1 input. So it was like this. This is the SRLH. For the flip-flop, instead of this, we now have a clock there. The other input is the clock. Now the circuit is synchronized. This is the SRS. I think there is no harm in calling it the SR flip-flop. I'm hoping there is no harm in that. But I'm just used to saying RS flip-flop. Right. To the operation now. As you can see, with the clock here, we want to find, let's find the output here and see how the clock affects the circuit. Let's find an output here and call it S star. Let's find an output here and call it R star. Using logic expressions, what is S star? Participation. Simple logic expression. What is S star? I'm listening. S star is equals to S star is equals to S NAND clock. True or false? Logic expressions. R is equals to R NAND clock. De Morgan's theorem. What is S star? Participate. De Morgan's theorem. What is S star? No, I'm going to go on. Minus 15. What is S star? I'm listening.
S bar
S star is equals to S bar plus clock bar. Yeah, we have R bar plus clock bar. Now, if the clock is 0, what happens if the clock is 0? What is S star? clock is equals to 0, what is A star? If clock is equals to 0, what is A star? What is R star?
See,
Participate. I know there is only 15 of you, but this is simple logic gates. If clock is equals to 0 here, what happens to A star? No one to participate. It's a day.
Isn't it S bar?
It's not S bar.
Isn't it S bar plus 1?
Ah, yeah. Ah, yeah. Logic design was sharing.
0.
This type is one.
If I have an AND gate, if I have a 0, in fact, let me put an AND gate. A, B, F. 1, thank you very much. 0, 1, 0, 1. 0, 0, 1, 1. Here for an AND gate is 1, 1, 1, 0, right? Wherever you have a 0, the output is 1. We have a 0 here, we have a 0 here. The output of a NAND gate is 1. Doesn't change. That does not change. Here we have a 0. The output of a NAND will be 1, 1. And what is Q? What is Q for that NAND? Here, what is the output Q? If here I have a 1, if I have a 1, what will be the output? Oh, yeah.
Illegal.
Illegal. Nope, it's not illegal. It's not illegal. Okay, let me put it in a different way.
Yes.
Let's start
Yeah.
with this. If clock is 0, we understand S star is equals to 1 and R star is equals to 1. For a NAND though, the one we dealt with, which is in the illegal state, there was no rows here. It produces an illegal state. But this one is the opposite with the NANDs. I think when we began, I gave out this information. If I have an SRLH, active low, NANDs, if an SRLH is made up of NANDs, I said it is active low. If it is made of NORs, it is active high. It means here when S is equals to 0, SR is equals to 0, this is your hold. But here is the opposite. This becomes my hold. Active low, active high. They are the opposite of each other. The one which is made of NANDs, if I had to explain everything using the NAND gates, you see there is a difference when I explained it using NOR gates. So coming back to here, if my S bar is equals to 1 and my R star is equals to 1, this is my memory state. This is a memory state. It's not my memory state, but it is a memory state. If clock is equals to 1, I'm hoping it can be clear with the next state here. If clock is equals to 1, what is my S star and what is my R star? Clock is equals to 1. S star is equals to S bar. R star is equals to R bar. Because if I put a 1 here, I get S multiplied by 1 bar. This is equal to S bar. All right. If I have an S bar and an R bar, then we have the states flip-flopping. Let's call this the flip-flop state. I will explain this with the truth table. Let's put out the truth table here. The truth table for the SRLH flip-flop, I mean. We have 2 inputs, now 3, S and R, and we also have a clock. 2 inputs plus a clock. What is my next state? The truth table. If the clock is 0, whatever the inputs are, we are in the memory state. And I explained it here. If clock is 0 here. If clock is 0, our S bar and our R star is equals to 1. And this means we are in the memory state. If the clock is 1, however, 0, 1, 0, 1, 0, 0, 1, 1. If the clock is 1, however, the circuit now functions as an SRLH. So for 0, 0, we have another memory state. For 0, 1, this is the reset state. For 1, 0, this is the set state. For 1, 1, illegal state. The difference between the truth tables of the flip-flop and the latch is here. We have a clock on the other one. We don't have a clock on the other one. The characteristics table will be almost the same as the one for the SRLH. So this is the truth table. The characteristics table, The characteristics table shows you what is the next state. How do you find the next state? It aids in finding the next state. So we have my present state Q, I have my inputs S and R, I have my next state Q plus. So if my inputs S and R are 0, 0 here, 0, 1, 1, 0, 1, 1. Let's say I have an input 1 here. What is my Q plus? Anyone participate? What is my Q plus? Q plus is equals to Rumbidzai. What is Q plus? If Q is equals to 1, what is Q plus? This is how I measure your level of understanding.
Memory 1.
Memory 1. Thank you very much. Pana sirudzi one way up baby re. Vangu vese vakanyarara. Pana sina kuziva one up baby re. Let's start there. Because we cannot move. There are 14 people inside this session, in the session. Mese makanyarara padaisa one. Ko ndikaisa one pana. What is my Q plus? Here.
Zero. Tingeta reset sakainga zero.
Enter reset and get zero. Right. Madam Abuda to one up the two. One argu papa truth table up. From the truth table, I know that if my inputs are 0, 0, we have what we call a memory state. What does the memory state do? The memory state keeps the current state. So my current state here is 1. What will be my next state? It remains 1 because I have a memory state 0, 0. That's this figure. This is important information, by the way, because partial zenye sopinda kuma counters. A counter rinenge ma flip flops akadai akabatana rimwe pangoruka kune gate kunoko rodzoka apa rimwe rakabatana apa akadai output 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 maybe rinobata ukunoko. This is a sequential circuit. Now, if you don't understand how this basic 1, 2, 3, 4 is functioning, how will you understand how the 4 of them function altogether? It's very important to understand how one basic element is functioning and how it functions. It begins with understanding these truth tables right there. So, Madam Abunda, that now this sort one baby. Do you now get where the 1 came from? I'm listening. Nope, she's disappeared. All right. Pana comrade don't go with zeros always my 0 paper. Right. So if I have a 0 here, what will be my next set? What will be my next state here? Take a wild guess if you don't know. I need people to participate. So I measure your level of understanding before moving on. Don't remain silent. If I have a 0, it becomes a 1. And if I have a 0 here, what? What is the state here? What is the next stage? This is an illegal state. All right, I repeat. You need to understand what is the memory state, what is the reset state, what does it mean? If you understand that, then you can then go and work with a lot of these basic elements in a sequential circuit. If you don't understand, however, it's trouble, ladies and gentlemen. This is where I lost it here. Understanding that what memory is. And I'm willing to explain until you get what these memory things mean. So what I have here is an S and an R. 1, 2, 3, 4. 0, 1, 0, 1, 0, 0, 1, 1. So I have a Q. I have a Q plus. Next state. Madam Wanyara, I need you to say something. Who was that? If my state here is 0, if my state here is 0, what will be my next state? Let me pick out some names. Rwafa. Don't go to what is my next state? Unmute yourself. Rwafa. What is my next state? Yes, I need an answer. Rwafa. What is my next state? If I have a 0 here, what is my Q plus for the SR flip-flop? Awusikuziva here or usoda kupindura? Makatovharwa. The thing is, you need to communicate kuti ndakatovharwa. Because ukanyarara, it will not help. 10 minutes. Right. My next state is determined by this truth table. I will repeat until somebody gets something. Wafa, my next state is determined by this truth table here. This truth table says if my S and my R are 0 here, what does this state mean? It means it's the memory state. This is very rough. Memory state is not whatever your present state, the next state will be equal to your present state. That is what memory means. Your present state is stored. The next state will be equal to the present state. That is memory. You get the memory state only when you have your inputs 0, 0. So here, Wafa, I have inputs 0 and 0 SR. What will be my next state? Let's talk. Give me an answer. Rafa.
This 0.
This 0. Why it's 0? Because we stored this state. This state is in memory. So if I have a 1 here, who else? If I have a 1 day, what will be my next state?
One Wednesday.
It will be 1 because I have memory state. I'm storing this 1. That's all. 2 things you need to know. Memory state. If I have a 1, next state 1. If I have a 0, next state 0, because I'm in the memory state. Possibility number 2, I have the reset state here. If I have S is equals to 0, R is equals to 1, my output, my next state will be 0, whatever the input. It will be 0, whatever the input, because this is the reset state. So if I put a 1 here, what will be my next state? Rafa.
If you put a 1 there.
Yes.
It should be 0.
Nope. Give me an answer. If I input a 1, what is the answer? Not it should be.
0.
Yeah, it should be 0. The answer is 0. Why? Because this is the reset state. The reset state, I have 0, I have 1. I have 0, I have 1. The output will be 0. This truth table doesn't change. This truth table, it does not change. Your understanding of it, though, can change here. Because if I have a, for example, if I have a 0 here, whatever the input, since I'm on reset, it will be a 0. If I have a 1 here, whatever the input, it will be a 0. And for this state, let's say I have a 0 here. Rafa, what is my output? My next state.
The set.
Next
table.
state
So
is,
set to be 1.
that would be 1 because we are on the set state. Everything is coming from this truth table. Voila. And that is how we are coming up with these ones and zeros. So the thing is, if you manage to cram this and you don't understand how it works, maybe in an exam, I'll just give you something like this. Characteristics table. I'll give you a characteristics table. Instead of going the true characteristics table, it has 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0. It is a Q, 1, 2, 3, 4, and 1, 1, 1. It's like this. Let's say you crammed this one. What I'll do in the exam, I'll just come and say, where are we in Africa? Yeah. I'll just give you this. This is my Q. This is my S and R. This is my Q plus. Find what is the next state for the following. 1, 0, 1, 1. 0, 0. 1, 0. God, learn to meet yourself, comrade. Here I have a 1, 1. Here I have a 0, 1. Right. Rafa, I'm dealing with you today. What is my next state here?
So that's the memory state. So it should be 0. It's 0.
Right. Memory state, Rafa, what does that mean? 3 minutes. It means my present state is equal to my next state. Is my present state equal to my next state, Rafa?
Nope.
No. I have a 1 here. Murwana ziliti garage coverage.
This is 1.
Kufoira exam koko. Number 2, Rafa. What is my next state?
That's 0. Yeah, 0.
All right, Rafa. That's another fail. What is the name of this state?
We have set.
What is the name of this
Set.
state?
It should be 1.
The state is called set state because there is a 1, 0. 1, 0 here. Do you get it, Rafa?
Yeah, I get it. So you look at the SR.
Yes. You look at the SR, then you predict your next state. The next state, Rafa.
Say,
Yes.
when you said could we look at the SR apple, yekutanga iyo when you looked at the SR, pana 00 saka ifana kuti pa memory state.
Eka, it would be memory state, and my present was 1 here. Then my next state will be 1. That's memory though.
Okay. All right.
Rafa tapa 1, 1, 1, 1, 1, 1, 1. What is my next state? Look at the timetable, truth table.
It's 1.
It's 1. Rafaka.
Doesn't exist. It doesn't exist. It's
This
illegal.
is an illegal state. Then lastly, Rafa, what do we have there?
0, 1. It becomes 0.
It becomes 0. Congratulations. This is the reset state. This is how we work with these tables. This is how we work. And since I managed to make Rafa understand what I'm saying, everyone else, you are all Rafas, and you have understood what I've just said. This is the last time I'm saying it. Thank you very much for attending this session. All right, Mere Magadal. I need a list of these 18 now. Panamane Maple. Ato Buddha Tripa 14. Mato Salat 18. Let me see. Screenshot. Right. New. So Zwana, whoever you are, Jasper, Jambo, Chikwamba, Rafa. Let assignments, let submissions, even negotiating. We now have privileges. So when you come for negotiating multi-step animal screenshot, then I'll come up with this one. Thank you very much for attending this session. We meet, inshallah.